So, we're on the last lesson in the unit, equivalent expressions. Scan the lesson and list 2 headings you would use to make an outline of the lesson. Pause the video and write those down now. So here are 2 you could have written down. Simplify expressions with 1 variable and simplify expressions with 2 variables. This is one of the things, or actually 2 of the things that we're going to be doing in the lesson today. In your vocabulary startup, it says, when addition or subtraction signs separate an algebraic expression into parts, each part is called a term. The numerical factor of a term that contains a variable is called the coefficient. A term without a variable is called a constant. And like terms are terms that contain the same variables, such as x, 2x, and 3x. So let's make sure we understand what's going on here. So each of these, 3x, 7, and x, in this expression are terms. They're separated by the plus signs. Remember, it says when addition or subtraction signs separate an algebraic expression into parts, each part is called a term. So 3x, 7, and x are terms. 3 is our coefficient in this expression. Coefficients are numbers or factors of a term that contain a variable. So, if we look at this one, we can think of 3x as 3 times x. So because 3 is being multiplied times a variable, it is considered a coefficient. 7 is our constant. If we think about the word constant, it means all the time or ongoing. 7's value does not change, so that makes it a constant. It is constantly going to be the value of 7. And our like terms are 3x and x. They are like terms because they both have 1x in the term. Try and label this expression on your own. Pause the video and let's see how you do. So, in this one, 4n, 2n, and 9 are all terms. Remember, terms are separated by addition or subtraction, and in this case, we're using addition to separate the terms. 9 is a constant. Remember, constants don't change in value. 9 is always going to be 9, so we can call it a constant. And our like terms are 4n and 2n. They both have 1n attached to their coefficients, so they're like terms. Take a look at your real-world link. It reads, Andrew's mother gave him a computer game and $10 for his birthday. His aunt gave him 2 computer games and $5. The expression x plus 10 plus 2x plus 5, where x represents the cost of each game, can be used to represent Andrew's birthday gifts. So let's make sure we understand what's going on here. If x is how much one game costs, x is going to represent the cost of the one game his mother gave him, as well as 2x being the cost of the 2 games his aunt gave him, plus the $5 his aunt gave and the $10 his mom gave. So in the expression, what is the coefficient of the term 2x? And in the second exercise, how many terms are in the expression x plus 10 plus 2x plus 5? Pause the video and answer those 2 questions. All right, let's see how you did. The coefficient in the term 2x is 2. Remember, coefficients are always attached to a variable. Whatever the number is that is attached to the variable is the coefficient. So 2 is the coefficient in this case. And there are 4 terms in this expression. Remember, terms are separated by either addition or subtraction. And all 4 of these terms are separated by addition. So x, 10, 2x, and 5 are all terms. Now, in the lesson, like the headings we wrote down said, we're going to simplify expressions. And in this particular case, we're going to look at expressions with 1 variable. To simplify an algebraic expression, use properties to write an equivalent expression that has no like terms and no parentheses. Essentially, and write this down, to simplify is to combine until there is nothing else to combine. Y'all, I need to fix that. There is nothing else to combine. All right, so if we look at this example with the numbers, we see like terms, 3 and 3, and they're also both constants. So we can identify them as like terms. And when we say combine, we're meaning add them together. So we can add 3 and 3 and get 6. Or we can notice here that we've got 2 3's, or repeated addition, and multiply 2 times 3 and also get 6 that way. Now when we're looking at variables, x and x are like terms here. We can combine these like terms because they both have one x. And when we have one x and we add another x to it, that gives us 2 x's. Look at example number 1. We're going to simplify the expression 4 times 6x. So the first thing we want to think about is the operation that is indicated by parentheses. And in this particular expression, that's multiplication. So we can also read this as 4 times 6 times x. And notice what has happened in parentheses. We've got 6 times x grouped using the parentheses. Now, what operation allows you to regroup multiplication? That would be the associative property. Using the associative property, we can regroup 4 and 6 and put those two in parentheses. Those are both constants, and we can simplify 4 times 6. So, what's 4 times 6? If you said 24, you're right. So, we've got 4 times 6, and then we've got 24 times x. Pause the video and try these 3 expressions on your own. Simplify them using the properties that we've talked about so far. Okay, let's see how we did. In the first one, we're multiplying the quantity 3 times x times 11. Now here, notice I used the associative property and regrouped my 2 constants into the parentheses. I can multiply 3 times 11. That gives me 33. And I can multiply 33 times x to get 33x as my simplified expression. Now remember, simplified expressions don't have parentheses and they do not have any like terms. So we can always check to make sure if our answer is reasonable by looking to see if we have parentheses and like terms. Here we have neither, so we're in simplified form. Now look at B. We've got 1, 2, 3 terms here, and they're all the like terms. We've got one x, another x, and another x. And all of those together give us 3 x's. Now, if we were to identify the coefficient in front of one of these x's, that coefficient would be 1. Given the identity property, any number times 1 equals itself. So if we see a variable alone, we can assume that it is equal to 1x. And if we think in our heads, 1x plus 1x plus 1x equals 3x. All right, in our last one, we are combining 7x, 8, and x. Remember what I said about this variable being by itself. Its coefficient is 1. So we're going to use the commutative property here and reorder these so that our like terms are next to each other. So we switched x and 8 so that 7x and x are next to each other. Now we're going to combine those like terms. 7x plus x, or 7x plus 1x, equals 8x. And there's nothing to combine with the constant here, so that constant stays on its own. In example number 2, it says 3 friends will pay X dollars each for admission to the museum plus $1 each to view the mummy exhibit. A 4th friend will pay admission but will not view the mummy exhibit. Write and simplify an expression that represents the total cost. All right, so let's think about this. What is the cost of admission? The cost of admission is unknown. It's being represented by an X. So X dollars is the cost of admission. Okay, what is the cost to see the mummy exhibit? Well, it costs $1 for each person to see the mummy exhibit. How many friends will view the mummy exhibit? So let's think about this. 3 friends will pay X dollars each for admission to the museum, plus $1 each to view the mummy exhibit. So that means 3 friends are paying to see the mummy exhibit. So we're starting to develop something here. How many friends will not view the mummy exhibit? Will not view the mummy exhibit? That's the 4th friend, so that's 1 person. 1 person will not, 3 people will. All right, what expression represents the cost to get into the museum? Now, the expression that's going to represent the cost to get into the museum is X plus 1. Remember, X is the cost of admission, and we've got 3 friends that are also going to the exhibit in the museum. So that means they're going to pay X dollars for admission and $1 for the mummy exhibit. What expression represents the cost of 3 friends all together? Well, if 3 friends are going into the museum and seeing the exhibit, we're going to take X plus 1 and multiply it times 3. That would represent the cost of 3 friends going into the museum and going to the exhibit. How will you find the cost for all 4 friends? Well, what we do know is that 3 friends are going to see the mummy exhibit plus their admission. And then we have 1 friend who's going into the museum but not seeing the mummy exhibit. So that means we're going to add on the cost of 1 extra admission, but not add on the cost of 1 mummy exhibit admission. So our total expression is going to be 3 times the quantity, X plus 1, plus X, where X is the cost of admission. Now, if we want to simplify this expression, what we're going to do is use the distributive property. Remember, the distributive property has us taking our coefficient on the outside of the parentheses and distributing the multiplication over the addition sign to both terms inside the parentheses. So if we use the distributive property, we get 3x plus x plus 3, or 3x plus 3 plus x. The commutative property allows us to take the like terms and put them next to each other. Here before, we had 3x plus 3 plus x, and then we switched these 2 around so the like terms were next to each other. If we combine the like terms, 3x plus 1x, that gives us 4x with that remaining constant hanging on the side. So the total cost for all 4 friends hanging out together is going to be $4 times x, or 4x, plus 3. Pause the video and try this one on your own. Recall that X dollars is the cost of admission to the museum, and $1 is the cost to see the mummy exhibit. All right, let's see how you did. Well, it says write and simplify an expression for the total cost of 6 friends to go to the museum if only 4 friends view the mummy exhibit. All right, so let's get our ducks in order. 6x, where x is the cost of admission, is the cost for all 6 friends to get into the museum. Now, the problem tells us only 4 friends are going to view the museum exhibit. So 4 times 1 is the cost of only 4 friends going to see the mummy exhibit. Now, if we add those together, 6 times x plus 4 times 1, that would give us the total cost of 6 friends going to the museum and only 4 friends viewing the mummy exhibit. So let's simplify. 6 times x gives us 6x, and 4 times 1 gives us 4. Remember, a simplified expression has no parentheses and no like terms. So when we look at 6x plus 4, we have no parentheses. And if we're looking to see if they're like terms, they are not like terms. 4 does not have an x attached to it, so it is not a like term with the 6x. That makes this a simplified expression. Now, let's simplify expressions with 2 variables. Properties can be used to simplify or factor expressions with 2 variables. Compare the effects of operations on numbers to the effects of operations on variables. Well, if you notice here, we've got 3 and 3 again. we've got those like terms. They're both constants and they have the same value. So we can combine those together in repeated addition and see that 2 times 3 represents the same thing as 3 plus 3. And then this 4 that is not a 3 gets added on its own. Variables work the same way. So if we've got one x and another x, we can see that those are like terms and combine them to get 2x. This y is not an x, so we can't combine it with the x's, and it stays in the expression on its own. So x plus y is the same thing as 2x plus y, combining only the like terms that we see. Let's try some. In example 3, we're simplifying the expression, the quantity 14y plus x plus 22y. So let's think this through. What are the like terms in this expression? Our like terms are 14y and 22y. They're like terms because they both have a y attached to them. Okay? What property allows you to change the order in which numbers are added? If we're just changing the order, that's the commutative property. Notice here in parentheses, we are changing 14y plus x plus 22y to x plus, now in parentheses, we're changing the order here, x plus 14y plus 22y. Let me recap. So we're changing the order of what's in the parentheses. At first, it was 14y plus x, and now it's x plus 14y. Notice what's happening here. We're trying to get these two next to each other. What property allows you to regroup numbers being added? That's the associative property. So now that 14y and 22y are next to each other, we can regroup them to combine those like terms. When we combine 14y and 22y, we get 36y. But notice we also have this x hanging out on the side. It's not a like term with 36y, so it just stays x plus 36y. Look at example 4. We're simplifying the expression 4 times the quantity 2x plus y. We've got two variables here. We've got x and y, but they're separate in terms. So if we're going to use the distributive property, first we've got to think, what operation is indicated by parentheses? That is multiplication. Multiplication means that distributive property means we're going to take this 4 and multiply it by both of the terms in parentheses. So we're going to multiply 4 times 2x and 4 times y. Remember, we distribute to both of the terms inside the parentheses. Will the number 4 be multiplied by only 2x? Not at all. We're going to distribute to both terms. So, what is 4 times 2x? And what is 4 times y? It gives us the simplified expression 8x plus 4y. And again, remember, simplified expressions do not have parentheses, so we use the distributive property to get rid of those, and they do not have like terms. So if we look at this, 8x and 4y are not like terms because they have different variables, and this does not have 1x and this does not have 1y. All right, in example number 5, we are factoring an expression with two variables. Our expression is 27x plus 18y. So let's think through this. When we're factoring, we have to use the greatest common factor, and we can use prime factorization to do that. So let's find the prime factorization of 27x and 18y. Well, the prime factorization of 27x is 3 times 3 times 3 times x. Notice here that 27 times x means that we still have to multiply times that variable. 18y is 2 times 3 times 3 times y. Same idea here. We don't know the value of y, so we still have to maintain that variable in our prime factorization. Now, To find the greatest common factor, we're going to circle the common factors. That was 3 and 3, and use 3 times 3 to find our greatest common factor. So, what is the greatest common factor of 27x and 18y? It's 9. 3 times 3 gave us 9. Now, when we factor out the GCF, what are we left with inside the parentheses? So let's look at this. If 9 is our greatest common factor, 9 goes into 27 3 times, with that x still remaining. Look up here. We've got a 3 and an x remaining in the prime factorization, so that 3x remains. Same thing here. We've got 2y remaining, so we're multiplying 9 times 2y. So to answer our question, when we factor out the GCF, what are we left with in parentheses? We're left with 3x plus 2y, those remaining factors that we identified in the prime factorization. Lastly, how can we check to see if we factored correctly? Well, if we take this expression, 9 times the quantity 3x plus 2y, we can use the distributive property. If we use the distributive property and get back to where we started, that means we factored correctly. So let's multiply. 9 times 3x gives us 27x, and 9 times 2y gives us 18y. So that lets us know that we factored correctly. Try these 3 on your own, and then we'll see how you did. Pause the video now. All right, let's look at E. 3x plus 9y plus 2x. Right now, we've got our like terms separated from each other by this 9y. So we're going to use the commutative property and switch those around so our like terms are next to each other. Now, we're going to combine those like terms. 3x plus 2x gives us 5x. And because 5x and 9y cannot be combined, they are not like terms, this is our simplified expression. F. We're simplifying, but we want to notice here that we've got a 7 outside of parentheses. That means we're going to have to use the distributive property to simplify. So let's distribute this 7. 7 times 3x gives us 21x, and 7 times y gives us 7y. Notice here that we no longer have parentheses, and we do not have like terms. 21x has 1x, and 7y has 1y. So they are not like terms. This is our simplified expression. In G, we are to factor 12x plus 8y. Remember those steps. We've got to identify our GCF. So we need to find the prime factorization of 12x. That's 2 times 2 times 3. And the prime factorization, I forgot my x here, times x. Forgot that. 8y is 2 times 2 times 2 times y. So we're going to circle our like terms, which is 2 and 2. So our GCF is 4. Now, when we have our leftover factors, 3x is what's left over after we've factored out the 4. And for 8y, 2y is what's left over after we factored out the 4. So inside our parentheses, we've got 4 times the quantity, 3x plus 2y. This is not a simplified expression, but it is a factored expression. We factored out the GCF, and all remaining factors are inside parentheses. Last one. Look at example number 6. It says, the farmer's market sells fruit baskets. Each basket has 3 apples and 1 pear. Use A to represent the cost of each apple and P to represent the cost of each pear. Write and simplify an expression that represents the total cost of 5 baskets. Now let's think about this. What expression represents the cost of 3 apples? Well, A represents the cost of 1 apple, so 3A is going to be the expression that shows the cost of 3 apples. What expression shows the cost of 1 pear? Well, that's just P. We're told that P represents the cost of each pear. So 3A, 3 apples, 1 pea, 1 pear. What expression represents the apples and pears in one basket? All of that together is going to represent the cost of 3 apples and 1 pear. And we know means add, so we're going to add 3a plus p. Now, what do you need to do, to find the total cost of 5 baskets? Well, if this is the cost of 1 basket, 3a plus p, we're going to take that expression and multiply it times 5. 5 times the quantity, 3a plus p, represents the cost of 5 baskets. Now, we've got our expression. Let's simplify it. Remember, simplify means no parentheses, no like terms. So we're going to use the distributive property here. We've got a 5 sitting outside parentheses. That means we need to distribute. So we're going to multiply 5 times 3a and 5 times p. 5 times 3a is 15a, and 5 times p is 5p. So our simplified expression representing the total cost of 5 baskets is 15a plus 5p. Now, try these guided practice problems on your own. Then you'll check your answers using the QR code at the solution station. Last, you'll submit your answer to the equivalent expressions exit ticket in Edmodo.